Hello and good morning to our lecturer, Dr. Anas. Today we are going to present our video which is Nozzle. Here are my group members. As you know, Nozzle used the first law of thermodynamics in its mechanism. What is mean the first law of thermodynamics? First law of thermodynamics, an expression of the conservation of the energy. Energy can change from one form to another, but the total amount of energy remains constant. Here are the history of nozzles. The nozzle was developed by German engineer and inventor Scotty in 1878 and Swedish inventor Gustav de Levelin in 1888 for use on a steam turbine. This principle was first used in a rocket engine by Robert Goddard. Most modern rocket engines that employ hot gas combustion use D-level nozzles. This is the example of nozzle. Nozzles are used commonly utilized in jet engines, rockets, spacecraft, and garden hoses. It is used to increase the velocity of a fluid at the expense of pressure.
We're going to be discussing about types of nozzles. As you can see, we're going to be discussing about three types of nozzles, which are jet nozzle, high-speed nozzle, and propelling nozzle. Firstly, jet nozzles. A gas jet, fluid jet, or hydrojet is a nozzle intended to inject gas or fluid in a coherent stream into a surrounding medium. Gas jets are commonly found in gas stoves, ovens, or barbecues. Gas jets were commonly used for light before the development of electric light. Other types of fluid jets are found in carburetors, where smooth calibrated orifices are used to regulate the flow of fluid into an engine, and in jacuzzis or spas. Secondly, high-velocity nozzle. The goal of a nozzle is to increase the kinetic energy of the flowing medium at the expense of its pressure and internal energy. Nozzles can be described as convergent or divergent. Convergent nozzles accelerate subsonic fluids. If the nozzle pressure ratio is high enough, then the flow will reach sonic velocity at the narrowest point. In this situation, the nozzle is said to be choked. Divergent nozzles slow fluids if the flow is subsonic, but they accelerate sonic or supersonic fluids. Lastly, propelling nozzle. A propelling nozzle is a nozzle that converts the internal energy of a working gas into propulsive force. It is a nozzle which forms a jet that separates the gas turbine, being gas generator, from a jet engine. Propelling nozzles accelerate the available gas to subsonic, transonic, or supersonic velocities depending on the power setting of the engine. For example, the internal shape and the pressures at entry to and exit from the nozzle.
Thermodynamics principle of nozzle. As we can see, the fluid is flowing from left to right. Initially, before the fluid enters the nozzle, it has the characteristic of high pressure and low velocity. As it enters the nozzle, it will flow out through the outlet, having a low pressure and high velocity. Then, the rate of heat transfer between the fluid flowing through a nozzle and the surroundings is very small, since the fluid has high velocities and thus it does not spend enough time in the device for any significant heat transfer to take place. Nozzles typically involve no work and any change in potential energy is negligible. But nozzles usually involve very high velocities. As a fluid passes through a nozzle, it experiences large changes in its velocity. Therefore, the kinetic energy changes must be accounted for in analyzing the flow through this device. It is important to remember that volume of mass that enters the nozzle is equal to volume of mass that exits from it. So the mass is constant. This theory is proven through Bernoulli's principle. Bernoulli's principle states that as the velocity of fluid flow increases, the pressure exerted by the fluid decreases. Some energy is in the random motion of molecules, which we observe as pressure, the energy in this random motion is converted into faster forward motion known as stream flow. This change makes the pressure drop.
There are few applications that utilize in principle of nozzle. Okay, number 1, turbofan exhaust. The exhaust section of engine to provide a better velocity forward thrust. Number 2, spray and nozzle. It is provide uniform pattern fluid coming out from the nozzle. The third one is vacuum cleaner nozzle. It is provide a high speed velocity. Moving to my second topic, which is how to conserve the mass of nozzle. The conservation of mass is fundamental concept of physics. The conservation of mass tells us that the mass flow rate m dot through a tube is constant and equal to the product of density, velocity and flow area. The conservation of mass, it can be calculated through the mass flow rate. Mass flow rate equal density times velocity times flow area. Considering the mass flow rate equation, it appears flow given area and fixed density, which could decrease the mass flow rate and definitely by simply increase the velocity. Moving to my third topic, which is how to conserve the energy of nozzle. For flow through nozzles, the heat transfer, work and potential energy are normally neglected, and nozzle have one entrance and one exit. The conservation of energy becomes mass flow rate times H1 plus V1 square over 2 equal to mass flow rate times H2 plus V2 square over 2.